Right now, we are living through a story that is going to define our future, the story of artificial intelligence. And it all boils down to one single question. Are we building our greatest ever tool, or are we actually building our successor?
I know, it sounds like the opening line of some epic sci-fi movie, but this isn't fiction. This is a question being debated right now with dead seriousness by some of the smartest people on the planet. So how on earth did we get here? You know, if you really want to get a handle on where we're going, you've got to understand where we've been. The dream of an artificial mind? It's not new. It's actually an ancient myth, a kind of prophecy that's been bouncing around for centuries, long before anyone wrote a single line of code.
I mean, think about it. As far back as the 13th century, inventors were tinkering with these incredible clockwork machines that tried to mimic life. But the modern quest, that really started in 1950 with Alan Turing and his deceptively simple question, can machines think? That one question got the ball rolling, and by 1956, artificial intelligence was an official field of study. But the dream, well, it got way ahead of the reality. The technology just couldn't keep up with the ambition, and that led to what we now call the AI winter, a long, cold period where it felt like the whole idea might have just been a fantasy.
The first crack at it was super logical. It's called symbolic AI. The idea was to just teach a machine by feeding it rules. If this happens, then do that. Imagine trying to teach a computer to write a great novel by just giving it a dictionary and all the rules of grammar. I mean, yeah, technically it has all the pieces, but there's no soul, no creativity. It just can't handle our messy, unpredictable world. So yeah, the dream was basically on ice.
But here's the thing. While that old way was hitting a dead end, a totally different idea was bubbling up. An idea inspired not by rulebooks, but by, well, the squishy, 3-pound computer inside our own skulls. The sleeping giant of AI was about to wake up.
So instead of force-feeding it rules, the big question became, what if we could build a system that just learns on its own, simply by looking at a ton of examples? That's the whole idea behind neural networks. They're designed to mimic the web of neurons in a biological brain. And here's the truly mind-bending part. They learn without us having to spoon-feed them a single rule. They literally teach themselves.
The real key that unlocked all this power was a mathematical trick called backpropagation. To put it simply, it gave the network a way to learn from its screw-ups. Every time it got an answer wrong, it could tweak its own internal wiring to do a little better the next time. This wasn't just some small update. It was the mathematical spark that was about to light the fuse on a massive revolution.
For decades, this whole idea was kind of just simmering in research labs. And then 2012 happened. At this huge image recognition competition, a new neural network called AlexNet didn't just win, it totally annihilated the competition. Its error rate was just 15.3%. The next best, over 26%. This wasn't a small win, it was a total game changer, a seismic shift. The giant was officially awake, and honestly, the world was never going to be the same.
That moment, it kicked off an entire decade of just insane exponential progress. But the next huge leap, the one that really brought AI into our living rooms, came when it suddenly got really, really good at the one thing we thought was ours alone, language.
It all began with this deceptively simple title from a 2017 research paper, Attention is All You Need. This paper introduced something called the transformer architecture, and you have to understand, this was a revolutionary new design. It allowed these AI models to finally get context, to understand subtlety and nuance in language in a way that was just impossible before. This right here was the birth of the large language model, or LLM revolution we're living in now.
So, what can AI do today? Well, buckle up. It can classify spinal tumors from scans with, frankly, superhuman accuracy. It can spot a heart arrhythmia just from an EKG signal. It writes complex code and, believe it or not, pretty decent poetry. It can call and book a haircut for you, and you'd never know you're talking to a machine. And it can generate images from a simple sentence that are so realistic you can't tell them apart from a real photograph. And let me be clear, this isn't some far-off future. This is happening right now.
But with all this incredible power, you just knew there had to be a catch, right? A new set of really deep, profound challenges. It's like our story's hero isn't perfect, and now its own creators are in this huge debate about what they've actually built and what it could become.
Which brings us right to the heart of it all. Are these systems that can talk and create art just really, really fancy parrots?
just mimicking patterns they've seen a billion times? Or is there something more going on under the hood? Are they actually thinking? Could they be conscious?
Okay, so on one side of the argument, some scientists are seeing what they think are the first glimmers of self-awareness. These models are building these internal maps of themselves, sort of a computer's version of looking in the mirror. And it begs the question, right? If a simulation of a thing becomes absolutely perfect, is it still just a simulation? But then you have the other side, and they're arguing that consciousness is tied to our biology, to our wetware. They believe you just can't have the software of consciousness running on silicon. It's an organic thing, period.
And you can see this whole debate play out perfectly between two of the literal godfathers of modern AI. You've got Geoffrey Hinton, a pioneer of this whole field, who's now so worried he's sounding the alarm, saying his creation could be an existential risk and that we need to regulate it like yesterday. And then you have Jan LeCun, who basically says, hold on a second. He thinks today's language models are a total dead end, a flawed design that will never lead to true intelligence. He's convinced the real path forward is building AIs that learn by observing the world, just like a kid does, not by reading the entire internet.
And while these giants of the field debate the future, the dangers aren't theoretical anymore. They're here, right now. Deepfakes are making it almost impossible to trust what we see and hear. Disinformation can be created and spread on a terrifying scale. We're still wrestling with what they call the alignment problem. How do we guarantee a superintelligence will actually share our values? And on top of all that, this all comes with a staggering environmental price tag, with these models guzzling massive amounts of energy.
So, here we are, full circle. Back to that ultimate question. Where is this story going? Is this incredible thing we've built going to remain a powerful tool in our hands? Or is it on a path to becoming something else?
The futurist Ray Kurzweil, who's been tracking this stuff for decades, has a prediction. And it's as bold as it is chillingly specific. AI will reach human-level intelligence by 2029. Let that sink in. That's just a few years from now.
Now, if he's even close to being right, it means the original dream of AI's founders, what they call artificial general intelligence, or AGI, a machine that can do any intellectual task a human can, is suddenly within our grasp. But is it even possible? Or is there some fundamental wall between machine code and human consciousness that can never, ever be crossed?
But maybe, in the end, the biggest question isn't really about the machine's potential. Maybe it's a question we have to ask ourselves. Can we, the creators, stay wise enough and work together enough to actually manage the unbelievable power we've just unleashed into the world? The next chapter in this story hasn't been written yet, and right now, the pen is in our hands.